Let's leave natural light shadows for a while and talk about something different, artificial light shadows. Okay, artificial light shadows different from natural light shadows in that they use, instead of a shadow vanishing point, they use a shadow radiating point. So let's just see what that looks like. Let's say, let's have an instance here where there's a light bulb. All right, here's a light bulb, General Electric light bulb right here. And it's turned on, so we're radiating light out like this. Now, this shows you, this is going to show how it's different from natural light. Natural light, the sun's rays are parallel, but when you have a light source that's close to you, like a lamp or a light bulb or something like that, you have the radiation effect of the radiating lines of the light are now evident in the shadow. So let's call this point here shadow radiating point. Am I drawing off the paper? No, shadow radiating point. So you could call it SRP. Now, if I have a pole that is, by the way, this point is on the surface. If this is the ground, this point is on the ground. And if I have a pole standing here, and one standing here, one here, one here, and let's say one over here. So I have a series of poles in the ground here. If I draw lines from those poles to the shadow radiate, oh, that's the wrong color. I like to use blue for shadow. It's green. Let's use blue here. Shadow radiating point. Whoops. You could see, if you had a series of poles standing around a point on the ground directly below the light, what you would get is shadows going out this way. Now, you don't see this part in here. You only see the part that goes from the pole out. But if you had a series of poles and you had their shadows drawn, it would be easy to find the shadow radiating point by just following their shadows till they all meet together. But let's go ahead and show you how to draw these shadows. The shadow of this pole is here. The shadow of this pole would be here. The shadow of this pole, oh, really close. The shadow of this pole would be here, and the shadow of this pole would be here. So the shadows of these poles look like this. Here's one here, one short one here, and one here. So let's say you didn't have this here. Let's say you just had a series of poles and a light up there like that, and you saw these shadows here. Here's how you would find the shadow radiating point. You would just follow those shadows out till they cross, see? This one goes this way, follow this one to here, follow this one to here, and that's how you would locate the shadow radiating point in a situation like this. Just follow those through. So, like you say, if you had a photograph with the shadows in it, but you didn't know where the shadow radiating point was, you could find it very easily. So what we know then is that the shadow radiating point, in this case, gives the direction of the shadow. Remember, in natural light shadows, it was the shadow vanishing point. But with artificial light, the shadow radiating point gives the direction of the shadow. And then, as in natural light, the source, which is a light bulb here, the source gives the length of the shadow. So the direction of the shadow is determined by the shadow radiating point, and the source gives the length of the shadow. So let's see some examples of that. Let's find the shadow. Well, we did find a shadow of a series of poles. I think that's explained here. Let's show an instance here where we have an artificial light and find the shadow of a wall and a pole using artificial light. So in this case here, we'll need a horizon. So here then, it will be a horizon line and a wall going off to a vanishing point like this. And the two ends of the wall will be verticals, which we will treat them as though they were poles in the ground, and we will find their shadows. And then there will be a wall, not a wall, but a pole which will cast a shadow across the ground and onto the wall. So let's then locate here. I think what I'll do is I'll put the source up here and draw, let's put it maybe here. I'll draw down like this, and I'm going to pick a shadow radiating point on the ground here, SRP, and I'm going to put the source up here, Philips light bulb. Okay, that dot in the middle of the bulb is the source, actually. So let's just draw the shadow of the wall for now, using a shadow radiating point and using the verticals at the end of the wall as if they were poles. Draw through the base of this pole for direction, draw through the base of this pole for direction, then come from the source through the top of each pole for the length of the shadow. So here's the length of this shadow and the length of this one here. Once again, I don't need to do them both, because just by finding one and lining up with the vanishing point will give us the shadow of the horizontal line. So the shadow of the wall, let's say this wall is made out of smoked glass so we could see through it. There's the shadow, and then here's the visible part of the shadow down here. So now what I want to do here is have a pole that makes a shadow that goes to the wall and touches the wall and goes part way up the wall. So I don't know quite how tall to make that, to do that. So I'm just going to let it fade off like that. And I'll start the shadow. See, I'm an artist, and I'm going to construct this, and I want that shadow to do certain things. So let's make it do it. By drawing from the shadow radiating point, through the base of the pole, it gives me the direction of the shadow. Now what I want to have happen is I want the shadow to go up the wall and stop right here. That's what I want. How can I get that? Well, I can get that by drawing backwards like this. Drawing toward the source like that, so I can find the top. Let's make that dark enough that it can be seen. You can see then that the top of the pole should probably be right here. And I like to say the question that's probably in most people's minds is, okay, what if the pole were taller? What if it went even taller than that? Well, let's draw that. Let's say the pole goes clear up here like this, or the shadow anyway, and the pole is continuing on up like this. What would the shadow do then? Okay. What you do is go back to the original direction here and just continue it on the ground. See, it would go over the top of the wall like this. So that's how the shadow would continue. Then we come down from the source down to here. And this would give us the length of the shadow. So let's get rid of the excess up here. The new top of the pole then would be here, and its shadow would end here. I don't know if you can see that clearly. Let's get it in a little better. Okay. All right, so there is the shadow of a wall and a pole using artificial light. There's a very difficult one here that's called find the shadow of a box and two poles. I think maybe I'll need a new piece of paper for this, so let's do it here. Find the shadow of a box and two poles. It's a 2-point box, and I'll draw a horizon first. Horizon line. And a box in 2-point. Again, there's usually some problems with coincidences on this one, but maybe we can make it work. It's a 2-point box. And I want to be careful to avoid coincidences again. So I'm going to draw the hidden lines first. What I'm trying to do is prevent the hidden lines of the box from falling behind the visible lines. Okay. Let's make this hidden line here visible here. Then the two visible top lines here and here. So this is called find the shadow of a box and two poles. So what's happening here is that the box will cast its shadow, and then we're going to make two poles. One pole outside the box, casting a shadow on the box, and one sitting on top of the box, making a shadow. There's a particular thing about artificial light shadows, and that is a radiating point is required at every level upon which a shadow is cast. When we did the natural light shadows and we had a pole casting a shadow on top of the box, we just used the vanishing point, the shadow vanishing point. But in this case, it's necessary to find a shadow radiating point on the ground and also at the level of the top of the box. We need that. So what I want to do for this particular exercise is look at this angle right here. I want to put the shadow radiating point right in here. So I'm going to put that right here, SRP, shadow radiating point. And above that I'm going to put the source or the light. So up here we have a light bulb. Looks like another Philips light bulb. And I'm just going to see if this is going to work for me here. Looks like it could. So what I'm going to do then is draw the shadow of this box. Now I see from where that shadow radiating point is that this plane of the box here is in light and that plane back there is in light. These two planes here and here are in shadow. So knowing that, the break between light and shadow is this vertical here and this one here. That means those two verticals in drawing the shadow will give me the sides of the shadow. So lining up with the shadow radiating point like this, drawing through the base of this vertical for direction, and through the base of this vertical for direction, pretending that those verticals are poles. Now drawing from the source, that's the light bulb, through the top of each one of those poles, I'm finding the lengths of their shadows down to here, and then down here. Okay. Knowing then that the two sides of the box are making shadows like this, I know that these two lines will also make shadows. See, the top is in light, but the side is in shadow. So I know that the shadows of those two lines will go to the same vanishing point those two lines go to. This line starts at this corner, find the shadow of this corner, and draw to the same vanishing point. Okay, this line starts at this corner, find the shadow of that corner, and draw to the same vanishing point for that. The VP is here. Okay, now you have the shadow of this box, which is, the box is made out of smoked glass so we can see through it. Then we have the visible shadow here, okay? So let's not scribble too much on there because we got some difficult things to do here. One of them is to locate a pole between the shadow radiating point and the box in such a way that it will cast a shadow on the box. So what I'm going to do here, in order to make that work as an illustrator, I'm going to draw the shadow first so I'll know where it's going, okay? So let's start here like this. The shadow will be here. Somewhere there's going to be a pole on that line. But now I want that shadow to meet the box and go up on top of the box, and then I want it to go across the top of the box. But look, I can't use this line anymore, or this point, because the shadow won't be going in, it'll look like it's changing direction. The shadow has to continue going in the same direction. In order to do that, I need a second shadow radiating point, and this one needs to be on top of the box. There's a number of different ways that I could get it. One way is I could take the two sides, the top, let's say the top and bottom of this side of the box here, and what I could do is just put an arbitrary vertical right here between these two, and I could use that, that's the same height as the top of the box. By drawing from the shadow radiating point through the base of that, I could get a reference point up here and use the reference point to project this back here. And this gives me what I call SRP2 on the top of the box. Now I can use that to draw the shadow on top of the box right here, coming from SRP2. So that's pretty important, knowing how to do that. You need a shadow radiating point at every level upon which a shadow is cast. Now I can come here to this line where the shadow of the pole is, and I can draw the pole vertically like this, and then I can draw the red line to determine how tall that pole should be to get this effect. And that means the pole should end right here, and it will give me a shadow going across the ground, up the side of the box, and onto the top of the box. So the shadow then, from shadow radiating point 1, whoops, wrong color, shadow radiating point 1 to here, like this, then going vertically up the side of the box like this, then resuming, going on top of the box till we meet the red line coming from above. That gives us the shadow of that pole cast on top of the box. Now it calls for 2 poles. So there's a second pole that sits on top of the box. So let's put that, say right here, this one's on top of the box. Now I don't know how tall to make that just yet, but let's use it this way. Now because it's on top of the box, that means I have to come from shadow radiating point 2. See, because that's at the level of the top of the box. So coming from shadow radiating point 2 through the base of this pole, I'm finding its direction here. Let's make sure we can see that it comes from radiating point 2, like this, till it comes to the side of the box. Now here's the thing. When we plot down the side of the box, this can't be a shadow, because you can't have a shadow on a shadow unless you have a reflective plane someplace, or you have a second light source. So we're going to use a construction line rather than a shadow line. A construction line coming down like this. Now I'm going to resume drawing from shadow radiating point 1 like this through the base of that, carrying that line of shadow on out. How far does it go? Coming from the source through the top of the new pole here gives us the length of its shadow, which by coincidence I seem to have made just about right. So then here's the top of the pole here. So what we did here, we drew the shadow of a box and 2 poles, one on the ground near it and one on top of it. Okay? Let's find the shadow of a box and 2 poles in artificial light. What about, say you, how do you draw the shadow of a tilted pole? What happens when a pole is tilted? Well, say you're backing your BMW out of the garage and you run into a metal pole on the ground, and it doesn't just bend, it tilts. It tilts the pole over. So let's find the shadow of a tilted pole. Find the shadow of a tilted pole. Okay, I don't really need a horizon line for this. What I could just do is draw the pole. So what I have here is a pole tilted at an angle. But not only is it tilted at an angle like this, it's also tilted toward me. So what I'm going to do is draw a line on the ground, not a shadow, but it indicates the direction that the pole is tilted toward me. It's not just sideways, but it's tilted, okay? Toward me, or angled toward me, let's say it that way. So by drawing a line from this end of the pole down to here, I'm finding, again, an end base. That is that perspective term used for a point on the ground below something, all right? End base. Okay, let's locate then the shadow radiating point and the source of light. This is a Westinghouse bulb. Okay, drawing then from the shadow radiating point to give the direction of the shadow, what I will do is treat this line from the end of the pole to the end base. It's a false pole, but let's pretend that it's real, and let's draw its shadow. But what we actually get is a false shadow, so let's draw it this way. I'm not using blue because it's a false shadow. I draw a line in this direction, giving the direction of its shadow. Shadow radiating point gives direction. Coming from the source through the top of the pole, this gives me the length of the shadow, and it would end here. Now this is not the shadow. It's a false shadow because that's not a real pole. The real pole is here. Because it's straight, all I have to do here is come from this point that I've just found and draw back to the base of the pole, and there's the shadow. That's the actual shadow. So what I did was I found this ball at the end of the pole here, and then from there I drew the shadow of the pole. Shadow of a tilted pole. All right.